Factoring polynomials. So we're going to be factoring trinomials with something that I like to call the AC method. And so this is useful for when there are trinomials in standard form, which is here, ax squared plus bx plus c, where a, b, and c are just numbers, like a 2 or a 5 or even a 0. You can have a 0 as well. So let's look at example number 1, not 5, number 1, and let's look at the steps as well. So step 1 is insert any missing terms with a 0 for a coefficient. So if you're missing one of these, either A, B, or C, make sure you put a 0 in its place before you continue. So x squared I have, bx I have, and c I have. So now let's find out what A, B, and C are if there is not a GCF. So make sure there's not a greatest common factor you can divide out first. So 3, 13, and 10 have no numbers that I can divide out from all three. X squared, x, and then no x's. I cannot divide an x either. So there is no GCF either. So now let's figure out what A, B, and C are. So A is 3, B is 13, and C is 10. A is always the coefficient of x squared, B is always the coefficient of x, and C is always the constant. So to start factoring, we are going to multiply the A and the C term together. So I'm going to actually put the variables back, and you'll see why here momentarily. So A times C, so 3x squared times C, which is 10. So multiply that together, and you get 30x squared. So what happens is really what you need is you need numbers that will multiply to be 30x squared, but also add to be whatever b is. In this case, b is 13x. So the easiest way to do this is start from the top of your factors. Everything is divisible by 1. So if I do 1x times 30x, well, 1x times 30x does in fact give us 30x squared. But do they add to be 13x? Let's find out. So if I do 1x plus 30x, well, that's going to give me 31x, which is not the 13 that I need. So these are not the correct numbers. So then we move on to the next one. Well, can I divide 30 by 2? Yes, we can. 2x times 15x. So 2x times 15x makes 30x squared. And if I add these together, well, we get 17x instead, which is still not 13x. So that's not going to work either. So then we think, well, 3. So 3x times 10x, that does in fact make 30x squared. Let's try to add these up. 3x plus 10x, there is my 13x that I have been looking for in this process. Now, why do we need 13x? What we're going to do is we're going to take the original problem. So I'm going to rewrite the original 3x squared plus 13x plus 10. And we're going to break apart 13 into the two numbers we found in our table. So what this becomes is this becomes 3x squared plus 3x plus 10x plus 10. And now look and see, make sure that these still add up to be 13. These are like terms. So if we were trying to simplify, this would be adding up to give me 13x. 3 plus 10 makes 13. Now that we have split apart and there are 4 terms, we're going to break this in half. Dealing with 2 terms is easier than dealing with 4. So let's look at just these first 2. 3x squared and 3x. We're going to divide out a GCF from just the first 2. So I know that I can divide both of these by a 3 and an x, because one is x squared and one is x. So just like the GCF, we're going to drop down the 3x on the side, and what's left over? Well, 3 divided by 3 is 1. X squared divided by x is an x. 3x divided by itself is a 1. Now, we're going to do that same process with the last 2 terms. So 10x and 10, what can you divide from both of those? Well, I can divide out a 10. I cannot divide out an x because this 10 does not have an x on it. So my GCF is a positive 10. Make sure you put that plus there. Times, well, if I do 10x divide out a 10, we get 1x. And 10 divided by 10 is a 1. Now, hopefully this part should look a little bit familiar to you. Now, let's look at the entire expression as a whole. If you notice, the 2 parentheses are exactly the same. So what happens is these 2 parentheses that are the same, that's one of the factors. So 1x plus 1 And then the other factor is made up from the two numbers that are outside. So 3x plus 10. So what we have done is, this is the factored form, x plus 1 and 3x plus 10. That is the factored form of this trinomial at the top. So factoring, remember, is taking this trinomial and breaking it down into what did you multiply to get that trinomial. Now, check your answer by multiplying the factored form back into standard form. I'm going to move this around just a little bit. I'm going to put the 3x plus 10 at the front, and I'll show you why. 3x plus 10 times x plus 1. So we're going to check and make sure this works. So if we were to multiply this, we would do 3x times x plus 1. And we would do 10 times x plus 1. Well, look at what you've done. This here is this step here. We're going backwards now. So let's see. 3x times x is 3x squared. 3x times 1 is 3x. 10 times x is 10x. And 10 times 1 is 10. Now look what you've done from step 2. This here is exactly the same as when we broke apart the b. Okay, now let's combine like terms. 3x and 10x combine up to make 13x. And there we have it. So we have exactly what we started with in the beginning. So what factoring is factoring is undoing all of this multiplication that you learned a while back. Let's do another one. So for example 2, we're going to factor 4x squared minus 9. So the first step is making sure it is actually in this standard form, ax squared plus bx plus c. Well, I have ax squared, that's this one that's here, and I have c, that's the negative 9. What I don't have is b. So when you're missing a term, what happens is we put it back in as a 0x. Normally it's the b that's missing. Not plus c, should be minus 9. Usually it's the b that's missing. And now that we have all three terms, we're going to approach this the same way we did number 1. So look for a GCF. Well, 4, 0, and 9, there are no like numbers that I can divide out of 4, 0, and 9. So we're stuck with what we've got. So let's multiply a and c. So remember, this is a and this is c. So 4x squared times 9 will give us 36x squared. So 4x squared times negative 9 will give us a negative 36x squared. And I have to add up to be b, that middle number of 0x. So again, some of you are very good with numbers and you're going to be able to do this without the table, but otherwise, start at the top. Now, how do you make a negative number when you multiply? Well, that means one of them has to be negative and one of them has to be positive. It doesn't matter which one's which, but one needs to be negative and one needs to be positive. So I'm just going to start with negative 1x times 36x. I know that will multiply to be a negative 36x squared. But if I add them up, negative 1x plus 36x, I get 35x, which is not 0, so this is not the correct number combination. So then we try the next one. Negative 2x times 18x. So we add them up. Negative 2x plus 18x is 16x. And again, that's not 0, so that's not going to work. I can divide by 3. So negative 3x times 12x. So negative 3x plus 12x. There's 9x. We're getting closer to 0, but still not 0. I know negative 4x times 9x will give me negative 36x. And if I add these up, I get 5x, getting closer. 5 does not divide into 6, but I know 6 does. So negative 6x times a positive 6x. And if I add these together, there is my 0x. So here are the two numbers that you will split b into. So let's split apart b. So we have 4x squared. The 0x gets split up into a negative 6x plus a 6x. One is here, the other one's here. And then minus 9. Now that you have 4 terms, divide it in half, divide and conquer. We're going to get the first two first. So take the greatest common factor out of 4x squared and negative 6x. So the greatest common factor is a 2 and an x. So 2x will drop to the side of parentheses, and then what's left over? Well, 4 divided by 2 is 2. X squared divide out an x, there's 1x left over. Negative 6 divide out 2 is negative 3, and x divided by x is gone. Look at the last two. 6x and negative 9, I can divide out a 3. So a positive 3, don't forget the plus, times 6x divided by 3 is 2x, negative 9 divided by 3 is negative 3. Now remember, these two should be the same inside. If they're not the same, we messed up somewhere. So now that those are the same, that creates one factor, 2x minus 3. And the other factor is from the outside numbers, 2x plus 3. So here is the factored form for 4x squared minus 9. 2x plus 3 and 2x minus 3. So let's look at number 3. We always need the front number to be positive. So let's look for a greatest common factor between 2, 6, and 18. Well, I can divide all of these by 2. But let's kill two birds with one stone. Let's do two things at once. If I want to make this front number positive, that means I need to divide out the negative as well. So this is the greatest common factor for these three terms. So negative 2 times, okay, well, negative 2x squared divide out negative 2 is a positive x squared, because there's a 1 on the front. 6x divided by negative 2 is negative 3x. 18 divided out negative 2 is negative 9. So now that we have taken out a common factor, this here is what we are trying to factor further. So this is your A, this is B, and this is C. So when we do our table to figure out what to split apart B into, we're going to use x squared and negative 9. So x squared times negative 9 is negative 9x squared. So I need two numbers that multiply to negative 9x squared but add up to be B, which is negative 3x. So again, start at the top. To create a negative number, I need one negative number and one positive number. So negative 1x plus a 9x is 8x. That is not the number that I need. I need it to be negative 3. So 2 does not divide into 9, but negative 3 does. So negative 3x times 3x. And if I add these together, I end up with 0x. Now, we've kind of ran out of factors. 1 and 9 and 3 and 3 are really the only two things that multiply to be 9. 4 does not divide into 9, 5 does not divide in, 6 does not divide in, 7 doesn't, 8 doesn't, and 9 gets us back at this factor here. We've already done that one. So what happened is there is no pair of numbers. There's nothing that I can multiply to negative 9 and also add to negative 3. So what that means is, that means this part right here is prime. That inside piece does not factor any further. So the factored form is simply taking out the GCF. This is my final factored form. That does not get any simpler. So sometimes all you can take out is a GCF, and that's it. Let's look at number 4. 4. So factor 2x squared minus 26x plus 80. So first things first is look for a GCF. Well, 2, 26, and 80, I can divide all of these by 2. So now what we're going to have is we have the 2 on the outside, and then what's left over will be x squared minus 13x plus 40. So now that we've taken out a common factor, remember, this is what we are factoring now. So you're going to have to make your own table. So A times C is on the left, and then adding to be B is on the right. So A times C. A is x squared, C is a 40. So 40x squared. So what numbers will multiply to be 40x squared, but also add to give me a negative 13x? So let's start at the top. 1x times 40x. And if I add those up, I get 41x, which is not what I need. So let's move on. I can divide by 2. 2x times 20x will give me 40x squared. And if I add these together, we get 22, which is not what I need. So let's try again. 3 does not divide into 40, but 4 does. 4x times 10x. So 4x plus 10x is 14x. That's super close, but not quite. Let's try 5. So 5x times 8x. So 5x plus 8x, well, that gives me 13x. Well, that's close, but I need negative. So how do you fix that? Well, what that means is 5 and 8 are in fact the correct numbers. They're just not the correct signs. So a positive times a positive is not the only way to make a positive number. You can also do a negative times a negative, and that will also give you a positive number. So 5x times 8x works, but so does negative 5x times negative 8x. Change the signs of both your factors and try it again. Negative 5x plus negative 8x, there is the negative 13x that I needed. So these are the two numbers that we will split apart b into. So what this turns into is x squared will drop down. Negative 13x splits into negative 5x minus 8x, and then 40 drops down. Now, you still have this 2 out in the very front. That 2 does nothing. He's just going to kind of drop down with us at every step because he has already been factored out. So he's just going to drop down on every single step that we do. So let's find the common factors. Let's split this apart. Let's deal with 2 at a time. So the common factor of x squared and negative 5x. Well, I can divide both of those by x. So we have x times x will be left over. X squared divide out an x is an x. Negative 5x divide out x is negative 5. Now, what about the right-hand side? Negative 8x and 40, I can divide both of those by 8. Now, remember what we said earlier. We always like this front term to be positive. So instead of an 8, I'm actually going to be dividing out negative 8. So if I do a negative 8, I will get a positive x left over because negative 8 divided by negative 8 is a 1. 40 divide out negative 8 is negative 5. And again, we still have that common factor of a 2 hanging out on the outside. These are in fact the same, so that is one factor. So x minus 5 is one of the factors, times x minus 8 creates the other factor. And again, we still have a 2 hanging out on the outside. Now notice I didn't put the big parentheses. And the reason why is all of this is being multiplied together. So there is no reason for an extra set of parentheses on the outside. I needed this extra set because there was some addition and subtraction in here. But because this is all being multiplied, we don't need that extra set of parentheses. So this is the final factored form of example number 4. So I want you to pause the video and I would like you to try example 5 on your own. So remember to first look for a greatest common factor between all three. And there is a common factor between 21, 35, and 14. Pause the video, try example 5 on your own. And here is your factored form for example number 5. So now I'd like you to try example 6. So remember, we need this in ax squared plus bx plus c format. So if you're missing one of these terms, remember to replace it with a 0 as its coefficient. So pause the video, try number 6. And here's your final factored form for example 6. 144 is a big number to multiply up to, but if you have to add to a 0, remember the only way to add to 0 is having the exact same number, one positive and one negative. So you could have started by trying 6 and 6, 3 and 3, 12 and 12, eventually would get you there. So when you have to add to 0, skip the process and it's anything in itself, one positive, one negative. Let's look at example number 7. What value or values of b could you use to make the following trinomial factorable? So basically, what number could go in here in order to make this trinomial here being able to be factored into something like this? So let's pretend we had a number. How would we start this process? We would look for a common factor. Well, 2 something and 9 won't have a common factor because 9 and 2, there's no common factor to take out. And I don't know what this is anyway. So the next step would have been a times c. Well, a is 2n squared, and c is negative 9. So 2 times negative 9 is negative 18n squared. And I would need to add up to be whatever b is, but I don't know what b is. That's the whole question. What could you make b? Well, let's just run through the factors here. So the first factor is negative 1n times 18n. So add these up. Negative 1n plus 18n would give me 17n. Then we could do negative 2. Well, negative 2n times 9n. So if I add these up, negative 2n plus 9n, we get 7n. 3 can go into 18. 3 times 6. And then if I add these up, we get 3n. 4 doesn't work, 5 doesn't work, and 6 starts over. But remember, a negative times a positive gives you a negative, but so does a positive times a negative, and you will end up with something different. So instead of negative 1 and positive 18, what if we did positive 1 and negative 18? Well, then if I added these together, positive 1 and negative 18, I would get negative 17n, so something a little bit different. So then what instead of negative 2 and 9, what if I did positive 2 and negative 9? Let's see. 2n plus a negative 9n would be negative 7n. And then again, instead of negative 3 and positive 6, what if I did positive 3 and negative 6? So change the placement of your negative. We would get negative 3n. So this is a complete list of all the possibilities of factors that multiply to negative 18n squared. So now let's look back at my original question. What values of b could I use to make this factorable? Well, let's look at some previous examples here. If I look back at example 4, we did our table, and then we picked these because this number gave me what b was. So if I don't know what b is, that means all of these are possible values of b. Any one of these will make this factorable because they are numbers that multiply to a times c and will add up to be 17 or 7 or 3. So you have lots of values. Basically, I have a positive 17 and a negative 17. So I can combine that as positive or negative 17. I have a positive 7 and a negative 7. So positive or negative 7. 3 and negative 3. So positive or negative 3. These are all values of b that could work. So there's actually 6 values that you could enter in for b to make this trinomial factorable. Anything else will result in a prime trinomial, so something that does not factor.